Okay, welcome to video 1 on accessing Kepler data utilizing our new web sheet. I've created a new Microsoft Excel spreadsheet called target list second set.xlsx, and it contains a variety of data here. This is old data, so you can look at this, but it's not trustworthy. Okay, this is old stuff just for type A stars. And if you look down here, there are multiple tabs on the bottom. The first tab is Target List Second Set, which lists all the stars by Kepler ID that we will be interested in and will be studying. And you can see each section has two columns of star IDs, and they're broken into subsets of spectral type. So you have the type A stars, and then getting cooler, the type F stars, type G stars like our sun, yellow, deeper yellow dwarfs, type K, and type M, which are the red dwarfs. Okay, so all these stars, remember, are main sequence stars. They're in the first 90% of their life cycle, so they have not left the main sequence, and theoretically they're all in hydrostatic equilibrium. I've then broken these out into subtabs A, F, G, K, and M. So if you look at the G, I've got a few here that have been sampled. Nothing for K, nothing for M. Let's look at the A's. I've sampled all of these just for grins and giggles using a really old Kepler data set. So all this data is incorrect, but to show you what it kind of looks like at this stage of the game, the first column is Kepler ID, a flag for is it periodic or not. I'm thinking that if it's periodic, we're going to put a 0. If it's quasi-periodic, we'll put a yes, we'll put a 1. And then we should enter the period, since I know that the period is probably not true. Let's go take a look at that star, shall we? So what I like to do is I'll copy the star ID, and then I will change over to the NASA Exoplanet Archive database, which we were talking about, and I will paste that in there. Make sure there are no spaces in here, just numbers. If you put a space after it, it kind of breaks the database. I don't know why, but there it is. So here's our star, 3231985, Kepler ID. Hit View, and it loads up all the available data sets that we can look at. I recommend at this stage of the game that we look at long cadence only, and we look at the latest quarter possible. So in this instance, quarter 16, long cadence, and tell it to view the time series, which is kind of ridiculous because no matter what you do, it shows you the time series for the very first entry, and we have to change it. Kind of ridiculous. So you look at the bottom here, and it's already selected quarter 0, long. Uncheck that, go all the way to the bottom, check the one for 16, long, and tell it to update the plot. And the plot will update, and it'll give you some data. The very first thing you should do is look at it. Maybe you can see that it's periodic. It looks kind of periodic. If you zoom in a little bit, it looks like there's some interesting activity here, which could be flares or some other kind of weirdness going on. Looks like a periodic pulsating flare star, which is kind of neat. You can reset the zoom and look at it that way. At the top, go to periodic, periodogram and phase curve, and tell it to compute a periodogram, but you have to tell it once again to select quarter 16 long, and then click on that, and then it says, hey, it's going to take a long time. You sure you want to do this? And you say, yeah. And then you go get a coffee. You talk to your friends, you go do some homework, you type a little bit on your English paper or your history paper, maybe do some research on variable stars. If you have a big enough internet connection, you might want to run several stars at once. So this is typical. It's telling me that it's gone through 15 seconds of compute time and it's still working. If you have to leave in the middle of doing something like this, be sure to hit the abort button at the bottom of the page down here. Okay, just beware. So it's done. And it's got kind of what I call a squelchy period. It's not a great period. It's strong, but not necessarily well defined. So there's a high likelihood of a period someplace over 10 days. So here's 1 day, here's 10 days. Looks like it's close to like 13 or 14 days. And we can scroll down a little bit to the bottom, and it ranks them by strongest to weakest. So period is 14.18 days. Let's click on the phased curve, and it will create a phased curve for us. And sure enough, I see a period there. definitely 14 point something days. You want that number, go back to the periodogram viewer, double click that, copy it, go back to your Excel spreadsheet and paste that back in there. So now we have a known period. You can give it some notes like it looks like it's a double graph, something unusual, and I think we'll probably just, we'll skip these two. Well, we might want to leave the variability cause. Here it says it's a pulsator for P, which is kind of neat. So we'll go from there. We'll discuss everything else. We might make some modifications to this over the next few days. For now, your job is to determine how you want to break apart all this data. So you got a number of stars here, and you have a number of students, and you can include me in the research, and I'm happy to look up my group of stars. So just in column-wise, you have 2, 4, 6, 8, 10. You have 10 batches of stars here by 5 spectral types. So you guys can figure out how you want to break those apart. Make sure that everybody does a number of stars, but you want to make sure that every star is done by 2 people for backup. Okay? And we'll make modifications to this database methodology as we see fit. And that's all I have for you. So thank you for listening.